Inverse functions. The rest of this chapter should be pretty downhill from here.
That's not good. Downhill good or downhill?
Good.
Downhill can be in the bad sense too.
That's good. This says 3.4. Yeah.
Oh, it's recording.
Tell me this. When you think of the word inverse, what do you think?
Inside out.
So let's say I give you a table. -2, -1, 0, 1, 2. What is that noise? Let's say I gave you that table and I said, make your best educated guess as to what the inverse would look like. What would you tell me?
Positives and then negatives.
You're thinking about a rule for the relationship that's there. I don't want a rule. I just want to know in terms of the numbers that are there, can you think of what an inverse might be? Mm-hmm. You're still thinking about a rule.
But you said an inverse, and you said that inverse of the rule would be.
Yes. Who said that? Good job. Switching the y and the x. That's pretty opposite, right?
Oh.
You thought that? You just didn't say that?
I thought I was wrong.
No, I said that was the G.
These are inverses.
Ain't that something like a G, yo? No, why? That something like a G. Or on G for the like a G.
Say it one more time, Shami, please. What's it look like to you? All right. So, you kind of see why switching the x and y would give us an inverse, yes? Kind of makes sense. Okay.
I got it.
You ready? What if I gave it to you in the form of an equation? And I said, what is the inverse of that equation?
Switch out the x and the y.
Absolutely. To find the inverse, I'm going to switch out the x and the y. Then I'm going to solve for the new y, because the new y is going to be my equation of my inverse.
You already learned this before?
But it's easy.
Like easy.
That's what I'm talking about.
It was actually enthusiastic.
I love that enthusiasm, I know. The rest of us are like, oh, it's a dreary, rainy Monday. And pump it up, Shamik, pump it up.
I bring this excitement to this class.
I love that.
All right, x equals 3y minus 5. If I solve this for y, what do I need to do? How do I know what order to go in? Because they're obviously not going to be all this easy. This is just an example of sad math. Absolutely sad math. So I want to add 5 first. Can you add 5 to x? X plus 5. And then what? Divide by 3. So this equation and this equation are inverses of one another. Okay?
That makes sense.
That makes sense?
You said the last 20 seconds.
What if And think about this graphically for a minute. I don't think so. Let's look at it graph. Well, let's do one more.
What if you have more than one X?
Right now,
There won't be.
yeah, for right now we really won't.
That bird's eye is just
2x to the third.
Now, let me tell you this. Let me give you some notation. This is what we call function notation. You remember us talking about function notation? Yes, ma'am. No, ma'am. Goodness gracious. All right, this is what we call function notation. How's it read? What do we say?
Y.
F of x, right? What you got there?
Y.
Yeah.
Yeah, I always think it's what?
It's just Y.
Here, we said that's f of x. The way we denote an inverse is we say the inverse of f of x, okay? So when we find it, this simply means, it's not an exponent of -1. This simply means the inverse of f of x. Okay, it's just a new notation for you. Don't let it intimidate you. All right, so looking here, several of you said a minute ago while the video was paused that this is the same thing as a y, right?
Yeah.
All right, so y equals 2x cubed, Juliana, put that away, plus 1. Yes? So now how do I find the inverse? Switch it. So I got x equals 2y cubed plus 1. Now solve it. What do I do first? Subtract 1. What?
So we just change that to y?
Then you square
Yeah.
root the fruit.
Close.
Divide it first.
Divide it first because I'm sad mapping. So I've got x minus 1 over 2 equals y cubed. Now what do I do? Cubed root it, absolutely. So the cubed root of x minus 1 over 2 is the inverse of f of x. Does that make sense to you?
Yes.
All right. Then, yes. When I divide it by 2 here, if my pen will work here. All right, let's talk about graphically what this looks like, and then we're going to verify, and then we'll be done. If I have a parabola. Now think about what inverses do. Inverses, we said the very first thing we determined was inverses switch what?
So
Opposites,
instead of
x and y,
being on the
right?
X-axis is going to be on the Y-axis.
Exactly. So what would this graph look like
So
if
the range would be different.
correct? What would it look like if I were to graph the inverse of this? Yes.
Well, that's how Landon grabbed.
And if you,
That's how he was grabbing looked at their crotch on the first lesson.
if you get confused,
I don't know what he was doing.
if you get confused, think about it like this. The point on the yellow is 2, 4, right? So on the inverse, that point should be
4-2.
4, 2, because x and y have been switched. Does that make sense? What it looks like graphically? We'll work some more with the graphs. I just wanted you to kind of be aware of the concept. All right, let's verify them.
That was the minute I caught that.
Something cool happens when we have inverses. And that is, now how, remember in geometry when you did proofs?
What's proofs?
Where you would make a statement and you'd have to justify it by a postulate or theorem or definition. And,
Oh.
Do like a little graph thing, you do like 0, 1, and 2.
no.
Never mind.
But think about this as an algebraic proof, okay? When two functions are inverses of one another, the first one we did was, what was that f of x we did just a minute ago? Y'all, come on, what was it? Something x cubed. 2x cubed, okay.
You knew that.
No, I couldn't remember. Instead of saying the inverse, let's call the other one g of x. It was x minus 1 over 2 cubed root of everything. All right. When two things are inverses of each other, two things happen. Number one, f of g of x will simplify to x. And
G of x is the inverse.
yeah. And g of f of x will simplify to x. This is kind of our way to prove that they are inverses. Okay? So what we do is we have to show that.
0
Equals x. It simplifies down to x. So this is one of those kind of problems where I'm giving you the problem and I'm giving you the answer. You have to show me the middle word. Okay? Show me why it equals x. And if I can prove that they both equal x, then I have proven that they are both inverses of each other. So, f of g of x. F of g of x is the cubed root of x minus 1 over 2. The important thing about this is that we go in the right order, which is PEMDAS. Am I going too fast? Okay, I'll slow down just a second. All right, y'all caught up? All right, so I'm going to plug this in. 2, it's not x anymore, it's cubed root of x minus 1 over 2 to the third plus 1. This equation, so it's 2x cubed plus 1 to x cubed plus 1.
Why did
We have to plug them into each other. All right.
Let's say x minus 1 over 2.
Mm-hmm. Now I'm telling you everything's going to cancel. But if you get on your test and you go all in one fell swoop, I'm going to mark it wrong. I know it cancels.
But it
I want you to
cancels, so you
show me, Shamik, the order in which it cancels.
That's right though.
What cancels first, Shamik? Yes.
you do the score? If we do the cube,
The 2.
we can.
The 3.
Same thing.
They cancel out. So now I've got 2 times x minus 1 over 2 plus 1.
Man, all that extra minute.
Now, if you want to distribute that 2 through to the top, be my guest. But if it was me, I know that if I'm multiplying this in the top and the bottom, they cancel. Yes? What's that leave me with now?
Minus 1 plus 1.
Oh, looky
It's
there.
just equals 0. X. Sorry.
Which is what I want. I have proved it halfway. In order to prove it the whole way,
Do the other one.
I have to come over here and do the other one.
What? Oh.
I was waiting on it. I figured you hadn't looked up yet if you couldn't say anything. What? Gotta do all that work?
And then we plug in 2x
Even
to the
Pepsi
third
Zero
plus
said
1
that.
into the x.
Yes.
It's
Yes.
still fresh.
So I take G this time, and in place of the X and G, I've got 2x cubed plus 1 minus 1.
So that's going to cancel all already.
What cancels first?
The plus 1
The
minus
plus and the minus 1. Don't cancel the exponents out first, even though that comes first, because a radical like that is a grouping symbol, just like a parenthesis. So we have to work inside there
just
first.
cancel out
So what you gonna cancel off first? The 1?
The ones on top?
Then you can divide by 2 by the 2's.
Absolutely. Then I can do the 2's.
I want to get the exponent out of the way though.
Well, you can't. You got to go in the right order. We all want to get it all out the way. Now, Shamik.
Now we get my boys.
Forwards and backwards, I get x, which means I have just verified that those two functions are inverses.
We'll have to do this.
Yes.
There's not a lot of things on our
And you
homework.
can-
Does it say 2x?
Oh,
What does that say?
2x cubed over 2.